Hey guys, it's me Kamal. I'm going to be explaining the week 10 math quiz for the AMS. Okay, so this is going to be the first time me doing the quiz, so I'm going to solve it, see at the end how much wrong we'll get and stuff. So let's start. So first in part A, they want us to find the derivative of each case. So here for part A, they say y equals to ln 10. The derivative of this is 0. Why? Because the ln of a number. There's no variable. There's no x or y or stuff. So here, the derivative of a number is always 0. So the answer here is 0. For part B, they give you y equals to x ln 3x minus 6x. Okay, they want the derivative. So first here, you look. X ln x looks like u times v, right? And this is a constant by itself. This is u. So you know that the derivative for u times v is u prime v plus v prime u. Okay, so what you do here now is you take each one. So u is equal to x, okay? And u prime will be equal to 1, okay? Because the derivative of x is 1. And v is ln of 3x, so v prime will be equal to, what was it? 1 over x, always. The derivative of ln, whatever it was, like if it was, okay, ln x is 1 over x, ln of 10x is ln 1 over x, ln of 3 million x is still 1 over x. The derivative of ln whatever x is 1 over x, always. Okay, so now what you do is you put this, you put all the things that you got in the formula. So u prime v, so 1 times ln of 3x plus v prime u, 1 over x times x, 1 over x times x. So here the x will cancel, so it will be 1. So ln of 3x plus 1. And then you found the derivative of this. Now to find the derivative of this, the derivative of, the derivative of minus 6x is minus 6. Okay. So now you just do minus 6 here. So it will be ln of 3x. 1 minus 6 is minus 5. So it will be ln of 3x minus 5. Ln of 3x minus 5. And that's the answer for this one. Okay, now for part C, give me a second. One second. Okay, so here they gave us y is equal to 1 over 3 ln of 2x3 plus 2. They want the derivative of this. So here, to find the derivative is, look here, the formula is the derivative of when y is equal to ln of u, and u is like an expression. It's like an equation, like this one, as it's here. So the derivative of this y prime is equal to u prime over u. Immediately, you just take the derivative of this over the original one. Okay, so here 1 over 3 stays how it is, 1 over 3 times u prime over u. U prime of this is 2 times 3 is 6, 6x squared over the original one. So 6x squared over 2x3 plus 2. And then here what you do, you start simplifying and stuff. So what you do here now, you can simplify let's simplify the 6 and the 3. So 6, you can divide by 3 and divide by 3. So it will be 2 in the top. So it will be now 2x squared over 2x3 plus 2. And in the denominator, you can take 2 as a common factor. So when it's 2x squared over 2, so it will be x3 plus 1, because you took 2 as a common factor. You can cancel out the 2 now. Now it will be x squared over x3 plus 1. And that is your final answer, x squared over x3 plus 1. And that's how to solve this question. Okay, so let me put in the answer. So 0 minus 5 and this. Okay, now moving on to question number 2. Here, which of the following is the solution to ln 3x over x plus over x plus 1 equal to 1? Okay, so here when you have like ln of something equals to 1 or like whatever, any number, okay, you can immediately think of e. You know, e is like it's a number like pi and stuff. So you can immediately make it, and you take the expression, okay, you take ln of, like, you take the equation, wait, which is 3x over x plus 1 is equal to e to the power of whatever number here, so it's 1. And if it was 10 here, it will be e to the power of 10, okay? And then you solve now for x. They wanted x equal, so you move this up there. It will be 3x will be equal to ex plus e. Okay, you can move the e there. So 3x minus ex plus is equal to e. Take x as a common factor, so it will be 3 minus e is equal to e divided by 3 minus e. So x will be equal to e over 3 minus e. E over 3 minus e. It's very easy. Okay. Question number 3. This is very, very simple. 6 ln x plus 5 ln y minus 4 ln z. Okay, so here you know that you can take, yani, when you have ln of x to the power of 4, how can you simplify it? It will be 4 ln of x, right? And here let's put it back how it was. So here it will become ln of x6 plus ln of y5 minus ln of z4. Wait, 4. Okay, so now here when you have two ln, like when you have ln adding each other, you can times their equations. Yani look, ln of p plus ln of q is equal to ln of p times q. And if it was ln of p minus ln of q, it will be equal to ln of p over q. Okay, it's very simple. So here you start doing by the first one. You start do the first one. Let's do it. So it will be now ln of x6 y5. Okay, and then minus ln z4. Now it's minus, so it will be ln of x6 y5 over ln of z4. So ln this one, it's that one. It's very simple. Okay, now moving on to question number 4. Okay, they want the value of b here. So they gave you the integral of 216 to 8 of 1 over 3x dx. They want it in terms of ln. Okay, so you know that the integral of 1, and here look, let's take, you have 1 over 3 as a constant. You can take it outside. So when you take 1 over 3 outside, it will still be the integral from 8 to 216 of 1 over x dx. And you know, when y is equal to ln x, the derivative is 1 over x. And if you want the integral of 1 over x, to put it back, it will be ln x. So this will become the integral of 1 over x is ln x. So now it will become ln x of 8 to 216 times 1 over 3, that's outside. So now here when you continue doing the derivative thing, the integral thing, so to be 1 over 3 of ln. Now you replace the 216 of 216 minus ln of 8. When you have two ln minusing each other, you can put it over. As I said in the previous question, ln of p minus ln of q is equal to ln of p over q. So now it will be 1 over 3 of ln of 216 over 8, which is 27. So 1 over 3 of ln of 27. But then, you know, and then they wanted a whole thing. They wanted ln of b, yani the total. So what you do here, you move the 1 over 3 there. So it will be ln of 27 to the power of 1 over 3, which is the same thing as ln of radical, the cube root of 27, which will be equal to ln 3. And so b here will be 3. And that's your final answer. Okay, moving on to question number 5. Same thing here. Okay, so they gave us the integral of 96 over 96 and 6 of 10 over x. Okay, you can take 10 as a constant, so it will be 10. The integral of 696, 1 over x dx. And you know the integral of 1 over x is ln x, so it will be 10 times ln x of 96 and 6. And then it will become, let me write it here, so 10 times ln of 96 over 6. And 96 over 6 is 16. So it'd be 10 times ln of 16. Here they want a, and they want here 4. How do you get 4? 4, you know that 16 is 4 to the power of 2. So it will be 10 times ln to the ln of 4 power of 2. You can move now the 2 there. 10 times 2 is 20, so it will be 20 ln of 4. So a here is 20. It was 20 ln 4. 20. Wait, wait 1 second. Okay. Question number 6. Okay, now here the same thing. Here now they want the derivative of ln x, which is, so here they gave us the equation of ln x7. They want the derivative, and then we replace the 1 over 8 as the x. So you know here it will be 7 ln x. Okay, when you have it's 7 ln x, but then after that, when you get it 7 ln x, it will be 7 times, because now it's c times u. Okay, so the constant stays constant 7, and the derivative of ln x is 1 over x. And now easily just take this and replace it, so it will be 7 times 1 over 1 over 8, and it will become 56. Or you can just go to the calculator, you can put the d over dx, put your equation, which is ln of x7. But then here they will tell you to put x as what? You put 1 over 8, and you'll find the equation, and you find the answer immediately. Or you can do it on the scratch paper like this, or you can immediately put it on the calculator. Question number 7. This is like we just did it. It's the same thing. So here the x will be 4, and then it will be 12, and then it will be 5. It's very simple. Question number 8. Okay, this one's also the same thing. Let me just do it. So here they gave the integral of 162 and 2 of 5 over x dx. Here, okay, look, they took 5 as a constant. So let me just do it here. So 5 as a constant. The integral of 162 and 2 of 1 over x will become 5 times the bracket of ln x of 162 and 2. See, same thing. But then they do the minus, so it will be 5 times ln of 162 minus ln of 2, which is the exact same thing as 5 times ln of 162 over 2. And then here 162 over 2 is 81, so it will be 5 times ln of 81. This is 81 here, okay, and then equals to, and here look, they found 3 at the end. Okay, so when they found 3 at the end, the base has to be 3. So 81 is 3 to the power of something, which is 3 to the power of 4. So it will be 5 times ln of 3 to the power of 4. Remove the 4 there. 5 times 4 is 20 ln 3. And that's your final answer. So here's 81 and 20. And then for part B, it's the same thing. Take 20 as the number. 16 and 2. 1 over x dx will become 20 times ln of 16 minus ln of 2. You know that. So it will be now 20 times ln of 8. Here the base is 2. You know, 8 is 2 to the power of 3. 2 times 2 is 4 times 2 is 8. So 2 to the power of 3. So it will be 20 ln of 2 to the power of 3. You move the 3 there. 20 times 3 is 60. So 60 ln 2. Okay, so here's 60, 81 there, and 20. So this is 81, 20, and 60. Okay, now question number 9. Okay, now that's the same as question number 1, but I'm gonna do it either way. So here they said if y is equal to ln 10, the derivative of a constant is 0. And then here, y ln 10 is 1 over 10, 1 over x, 10 over x. Why? Because I told you no matter what number is ln 10x, ln 20x, no matter what it is, it's 1 over x always. And then ln of 10 ln x. So it will be 10 times derivative of ln x 1 over x. So this one it will become 10 over x. And then part D, I told you when you have an expression, it will be u prime over u and then the constant. So 10 times 2x plus 2 over x squared plus 2x, which is, this one become now 5. We can move it up there, 1 second. You can, okay, so here it will be 10 times, you can factor out the 2 here, so it will be now 2x plus 1 over x squared plus 2x. But then you can times the 10 by 2, so it will be 20 of x plus 1 over x squared plus 2x. So the answer here is 20. Okay, so now here it is 0, 1 over x, 10 over x, and 20. Okay, now this one's also the same thing. So ln of 3200, which is, so here you have to like find the like factors and everything. So you take 300 and 3200 and factor it. So now this is 32 times 100. 100 is 10, 10, 5, 2, 5, 2. Okay, now that's it. And then the 32 is also 16 and 2, 4 and 4, 2, 2, 2, 2. You only take the last one. So this is 1, 2, 3, 4, 5, 6, 7, 2 to the power of 7, because there's 7 2's, times 5 to the power of 2. If you put in the calculator 2 to the power of 7 times 5 to the power of 2, it will become 3200. Yani, now it will be ln of 2 to the power of 7 plus ln of 5 to the power of 2. Because they want it in هذا. So now you move the 7, so it will be 7 ln 2 and 2 ln 5. 7 ln 2 and 2 ln 5. It's very simple. 7 ln 2 and 2 ln 5. 7 ln 2 and 2 ln 5. Question number 11. Okay, now this one's a bit tricky. First of all, they gave us if A, شو A? 1 second. Okay. So part A, they gave us the integral. I'm gonna write it here. The integral of minus 1 and 3 of 4x over x squared plus 1 dx. They want it ln k. Okay, now this one's a bit long, يعني بس no. So first of all, you have to do u substitution. So you take u as x squared plus 1. Then you directly find dx, which is equal to du. Dx is always equal to du over the derivative of this, which is 2x. Okay, and then you have to change the boundaries. So for x equals for x equals to 3, you will be equal to, so replace 3 here. So 3 squared plus 1 is 10. And then it's minus 1, so it will be 2. You will equal to 2. So that's a new boundary. So the thing now, new one is from 2 to 10 of 4x over u times du over 2x. Why du over 2? Because we found dx as this, and we found this as u. So now you can simplify this and this. So now it will be the integral from 2 to 10 of 2 over u du. Okay, now you found that. So when you do this, you can now take the 2 outside. So it will be 2 times the integral from 2 to 10 of 1 over u du. which is the same thing as 1 over x dx يعني, but no different, it's a u. So now you know that 1 over u, 1 over x, whatever it is ln x, ln u in this case. So it will be 2 of ln u from 2 to 10, which is this one, 2 times ln of 10 over 2, which is 2 times ln of 5, which now they want it here as a whole number. So you just take the 2 back to the 5, so to be ln of 5 squared, which is equal to ln of 25. And that's your final answer for this. This part A is simple, but part B is a bit tricky because you know the pi over 6 and tan and all of that stuff. Okay, so let me just take all of that. No, wait. Let me just move it about here, and let's do B. So they gave you the integral from 0 pi over 6 of 4 tan x dx. Okay, so first of all, you know that يعني, how can we solve this? We change tan as, let's do tan as cosine. You know that tan is sine over cosine, right? So first let's take 4 outside because it's a constant, so it will be 4 integral from 0 to pi over 6 as it is. So now it will be sine over cosine of x and sine of x, okay? So dx. And now you do that u substitution, you take u equal to cosine x, okay, du, and then dx will be all, as I said, du over the derivative of u. Derivative of cosine, you know, is negative sine x, okay? The derivative of cosine is negative sine x. You have to memorize this by now. Why do you take, like, why do you change it to sine over cosine, يعني, as terms of tan, and you take u substitution? So the end you can have all in one term. Here in this case, it's, see here when you find this, okay, so first let's change the boundaries. So for x equals to pi over 6 and for x equals to 0, u will be equal. So here now, for pi over 6, it will become, if you put in the calculator, pi over 6 will become, what was it? Pi over 6, and 1 second. Because I don't have my calculator, let me just check very fast. Cosine of 180 over 6. Okay, so this one will become radical 3 over 2, and then you know that, and then cosine of 0 is 1, I think. Yeah, 1. So now you have the new boundaries. So now the new boundary is it's 4 integral from 1 and radical 3 over 2. Okay, and then sine x over u, because cosine x is هذا, times du over minus sine x. Why do we, okay, so let me answer the question that I said before. Why do we change it to sine over cosine and do u substitution? So in the end, we can cancel out the sine, which we just did using the u here, this one, and so we can cancel now the signs here, so we can have 1 over u at the end, so we can change it to ln. Okay, so now here it will become 4 integral from 1 radical 3 over 2. When you cancel the signs here, it will become, the minus will stay, so it will be now minus 1 over u du. Okay, minus 1. 1 second. Okay, so now here, let's take the minus 1 as a constant. Let's take the minus outside, minus 1 in total, so 1 will stay inside. So now it will become minus 4 integral from 1 over radical 3 over 2 of 1 over u du. But then, let's flip the boundaries to remove the negative sign from the 4. because when you have a negative sign it's not it's هذا to remove the negative we flip the boundaries. The 1 will go up and the 3 will radical 3 over 2 will go down, so now it will become positive of 1 radical 3 over 2 of 1 over u du. And now you solve normally. It will be now 4 times ln of u of 1 radical 3 over 2, which now will become 4 times ln of 1 over radical 3 over 2. And then you put this on the calculator, you solve this, and then since this is a whole no, 1 second, let me move the ln there, just do this, ln of this. Okay, when you have this, they want it in a whole, right? Look, they want it whole. So now you just put the 4 here, so it will be now ln of 1 over radical 3 over 2 all to the power of 4. You put this, you only put this in the calculator, and then you'll find it as 16 over 9, yeah. So it will be now ln of 16 over 9. You put here 16. So here the answer we found is 25 and 16. So 25 and 16. Question number 12. Okay, so this one's the compound thing, which is, the formula, which is initial times 1 plus r to the power of n. Here they want n. We have the which is the total, okay? We have the total and we have the initial and we have the r. We need to find n. So it will be 1000 is equal to 10 times 1 plus 9% to the power of n. You put this in the calculator and you'll find n approximately 53. Sorry. And then question number 13. Wait, let me just do it. 53. Okay. So here the domain of x is always, it will be greater. Then you put this equal to 0. So x will be equal to minus 4. So greater than minus 4. Part B, as x approaching. Now first you approach it as the main number, which is minus 4 here. So as x approaching minus 4, when you place minus 4 in x, it will become y will approach negative infinity. It will be in the negative side, because here when it will be ln of minus 4 plus 4, which is ln of 0, and ln of 0 is when ln of 0 it will be in the negative. Okay, so it will be y approaching negative infinity. And then here x approaching positive infinity, y will definitely be approaching positive infinity also. Because here when a positive infinity, any number that's positive, it will become positive. To find the vertical, you just put it equal to 0, which is minus 4 we did in part A. And then the range, the range will be the y's. Y negative infinity to positive infinity. So negative infinity to positive infinity. Part D, here it is better thing is to just pick the graph and then do part D. So here find the vertical asymptote, which is negative 4. Here the vertical asymptote is this one. Okay, this is the first one. This is the first rule, not rule, the first clue. Is there any other graph that is vertical asymptote negative 4? No, so it is definitely the red one. So it will be the number 2. And then for part D, it's always increasing. See, it's increasing, it's going from down to up. And it's concaving downwards, because it concaved downwards, but it's increasing. And that's it. Let me submit and see if there's any wrong answer. What? 1 second. Yeah, okay, it's all correct. If you have any questions, any like if you got stuck in any question, feel free to ask me. And yeah, thank you for watching.